Hello! In this video, you'll be learning how to find the surface areas and volumes of similar solids. Okay, in the previous chapters, we've learned how to find the ratio of perimeter or ratio of area of similar figures. So now we are going to see how we can find ratio of, those are two-dimensional figures, so kind of the same idea applies for three-dimensional figures, but also volume would be new. Okay, so how to find, if two figures are similar, how can we find use their ratios to find the volume and area of each similar figure. Okay, let's look at an example here. Okay, they told us that these figures are similar, and then they gave us only one dimension for each one of them. And then they gave us the volume. The volume for this one is 27 cubic centimeter, the volume, and they asked us to find the volume of this one. Okay, so because there's no way we can find the volume of this unless we have the height and all the dimensions. But with similar figure, we can use one volume to find the other. Okay, and that's what we are doing here. Okay, one thing we need to remember is volume is a three-dimensional figure, but these side lengths are one-dimensional. And so before we can work with them, we have to make sure that we change this, we rewrite it to three-dimensional. That's what you need to remember here. Okay, so let's say you can set off a proportion. We can either do big over small, or purple over green, or green over purple. Either way, it's okay as long as you keep the order. So let's see, let's do big over small, which means the purple. Okay, so the big one, we can do the ratio of their volume. The ratio of the volume here is 27, it is cubic centimeter, over the volume of the small one, which is, we don't know, so we just keep it. That's what we are looking for. Okay, it has to equal the ratio of the corresponding sides. It has to be big over small also. But then, if you notice here, this is one-dimensional. The 6 over 4 is one-dimensional. See, for it to be three-dimensional, we have to multiply it by itself 3 times, 6 centimeter times 6 centimeter times 6 centimeter. Okay, so we have to do that before we can work with them. Times 6 times 6. Okay, this is times 4 times 4. It's getting messy. So this is the same thing as just writing this as 27 over V equals 6 cube over 4 cube. Okay, that's what will make them three-dimensional. Okay, so 6 cube is, which is 6 cube is 216 over 64. So we have 27 over V equals 216 over 64. Now we can cross multiply. Okay, so that gives us 216 times V equals 27 times 64. Okay, so 27 times 64 will give us 1728. Okay, and then if we divide that by 216. Okay, so the volume, that will give us 8. Now, it is 8 cubic. Remember, it is volume, so you need to keep it Again, so the same thing, remember that this is this times that, so we multiply these two and get this, and then we divide by this. Hope you remember that. Let's look at another one. Okay, so here we are told that these two are similar. They gave us the area now, because this is square unit. If it's a square unit, then you know it's area. It's two-dimensional. But the side lengths are one-dimensional. So again, we can do, let's try small over big. Okay, doesn't matter which order, as long as you maintain the order, small over big. So this is small. We don't know the surface area, so we'll keep the surface S. And then the surface area of this one is 196. Okay, this is two-dimensional. They are two-dimensional. Okay, we have to do this, the side length of the small one. Again, because it's two-dimensional, we have to multiply this 2 times to be able to make it two-dimensional. Okay, over. Then we have to multiply 2.8 2 times. If it is three-dimensional, we multiply it 3 times, but these ones are already in two-dimensional, so to be able to work with them. So S over 196, put this here to remind us that this is S, is not 5. Okay, 1.7 times 1.7, try that, we get 2.89 over 7.84. All right, now both of them are two-dimensional, so we can cross multiply, and then we get 7.84 times S equals 196 times 2.89. Okay, so if we continue and simplify, so S is going to be, if we multiply those two, we multiply these two with your calculator, you get 566.44. Then we divide by 7.84. Okay, so that will give you 72.25. Okay, cubic centimeter, square centimeter now, because it's area. So watch when you're finding volume and when you're finding the surface area, okay, and or the side length, right? And this one, let's find, they ask us to find the length, the height. These two cylinders are similar. The ratio of their areas, they give us the ratio of the areas. So we know these are areas. And then we're going to find the side length. Okay, so the same thing, we set up the proportion. Then if you like, you can do big over small. Here, they gave us the ratio 16 to 25. So 16 is smaller than 25. So we want to make sure you keep that order. So it means that this is small over big. So we just keep that small over big. Okay, so 16 over 25. Now, since we have that, we have to put the small on top. So 24. And since 24 is a one-dimensional, the height is a one-dimensional, so we must multiply it by itself to make it two-dimensional. Okay, so since 16 is area, is two-dimensional already. So the same thing we do with the height times height. Again, we multiply it by itself. So, or height squared, this height squared. So this is 16 over 25 equals 24 times 24 should be 576 over h squared. H times h is h squared. So now we can cross multiply. All right, so that is 16 h squared, 16 times h squared is equal to 25 times 526, so which is 25 times 5. Oh, this is 576. Okay, it's 576. So that's 14400. Okay, so on h squared means we divide both sides by 16. We divide both sides by 16. We get what? Divide both sides by 16. Divide this by 16, we get 900. Okay, so now we are solving for h, not h squared. So we remember this when we did Pythagorean theorem, how to remove the square. So we need to take square roots of both sides. So if we take the square root of both sides, so this square we cancel out, we have h, and then so square root of 90, square root of 900 is 30. So, and this is height. It is height. So it is not area or volume. So it is one dimensional. So we just put units. 30 units. It is not unit square or volume square or cubic square. It is just units because it's one dimensional. Okay, so whether you're finding the one-dimensional length or area or volume, the same process, you set up the proportion, but you want to make sure if you're using any one-dimensional for area, you have to multiply it twice. If you're using one-dimensional for volume, you have to multiply it 3 times to make it 3-dimensional. Okay, that's it.